Graph Data Structure Part 2. Adjacency List. Adjacency List.
An adjacency list represents a graph as an array of linked lists. The index of the array represents a vertex and each element in its linked list represents the other vertices that form an edge with the vertex.
Undirected graph. Linked list representation of the graph.
Here, 0, 1, 2, 3 are the vertices and each of them forms a linked list with all of its adjacent vertices. For instance, vertex 1 has two adjacent vertices 0 and 2. Therefore, 1 is linked with 0 and 2 in the figure above.
Directed graph.
0 is linked with 1 and 2 in the graph. 1 is not linked with any vertices in the graph. 2 is linked with 1 in the graph. 3 is linked with 1 in the graph.
Pros of adjacency list.
An adjacency list is efficient in terms of storage because we only need to store the values for the edges. For a sparse graph with millions of vertices and edges, this can mean a lot of saved space. It also helps to find all the vertices adjacent to a vertex easily.
Cons of adjacency matrix.
Finding the adjacent list is not quicker than the adjacency matrix because all the connected nodes must be first explored to find them.
Adjacency list code in Java.
First, create class graph. Add edges. Create the graph. Here, input the number of vertices of graph. Here, can add any edges of the graph. Finally, print the graph. The code is add edge 0, 1. The code is add edge 0, 2. The code is add edge 0, 3. The code is add edge 1, 2. It is undirected graph, so the matrix is symmetric.